Hello viewers, this is Teacher Nixon as usual. Today I want us to learn something on floating and sinking. Floating and sinking is a topic in Form 4 work, more specifically Chapter 3. And under this topic we are going to be learning various concepts, and one of the concepts is the Augmented Principle. The other concept is the law of flotation. We'll also be dealing with the relative density, and we'll finally be dealing with the numerical problems involving the law of flotation and the Augmented Principle. It is a very interesting topic that I want to believe learners are going to enjoy. I want to take this opportunity to welcome you, and I believe you are going to learn one or two things. To start with, I want to believe every one of us had ever seen a sinking object or a floating object. And sometimes we do ask ourselves, why do objects sink in water while others float in water? And I want to explain this in simple terms. We have a quantity that we learned in Form 1 in a topic referred to as Measurement 1, referred to as density. So when density of a given material varies or is different from the density of the liquid in which it is going to float, when it varies with the liquid in which it is put, that given material either sinks or floats. Now those given objects whose density is higher than the liquid in which they are put are going to sink, and those given materials whose density is less than the liquid in which they are put is going to float in water. And I want to briefly explain or give the relationship between density and other quantities like mass and volume, because this one will help us even to understand why some materials are going to float or some objects are going to float, yet their bodies are made up of materials that are more denser than the density of water or the liquid itself. So we get density as mass over volume. When volume increases, density decreases. And when volume increases, automatically density decreases. Now you might ask yourself, why does mass remain constant? We all know that, or we know that the particles, the number of particles making up a given object do not change, irrespective of whether that object is in air or whether that object is immersed in a given liquid. So that's why mass does not change. And I want to repeat by saying that an increase in volume leads to a decrease in density, and a decrease in volume leads to an increase in density. Now, this explains the reason why bodies like ships are going to float in water, and more specifically seawater, when they themselves are made up of materials that are more dense than water. Most of the body parts of ships is made up of steel and some other metallic materials which are far much denser than water. And a simple question that we ask ourselves is, why do those given ships float, yet the materials making up them is far much denser than seawater? And the simple explanation is this: the body of ships is made in such a way that most of it or most of the part is hollow. Why is it hollow? It is hollow so that its volume can be increased. And I have just mentioned that when volume increases, automatically density increases. So when those given bodies are hollow, it means that their density is going to be decreased, hence making them less dense than water. And that is the reason simply why you'll find ships floating in water, yet the materials making up the ship is denser than the water itself. I want also to talk about something else that we learned under a topic referred to as force in Form 1, and that concept that we learned is a force which we refer to as the Updrastic Force. updraft force plays a key role when it comes to floating and sinking. Objects that are immersed in water or in a given liquid will always tend to weigh less as compared to their weight in air. So when you weigh a given object in air, you will find that its weight is going to be less when it is immersed in a given liquid. And to make this clear, I have some instruments or some apparatus that I want to demonstrate with. I have a spring balance, and this spring balance is calibrated in newtons and also in grams, meaning that it can measure both mass and it can also measure both mass and weight. And I want to use this so that all of us understands this given force that we are referring to as the updraft force. I also have some masses with me, and the first thing that I want us to do is to measure the mass of this given body in air. Want to believe it's visible, but if not visible, I'm going to read it. Remember, always when taking readings on a scale, you should always position your eyes perpendicular to scale to reduce what we refer to as parallax error. So I can see the reading from my side is 1.0 newtons. 1.0 newtons. So we have seen the weight of this given object in air is equal to 1.0 newtons. Now I want us to immerse this given body in a given liquid, and this liquid that I'm going to use is water, and I want us to measure its weight when completely immersed in water and see the difference. I have a beaker with me, and this beaker contains some water, and this is where I want to put or to immerse this given body so that I can measure its weight when it is completely immersed. So I'm going to hang it here, and I'm going to immerse it gently and ensure that it is completely immersed in water. I'm going to take its reading. I have gotten its weight when completely immersed in water as 0.8 newtons. 0.8 newtons. Now, as you can see, this given body weighs less when it is immersed in water as compared to its weight in air. In air, it is 1.0 newtons, and in water, it is 0.8 newtons. I want us to get the difference between these two given values, which will give us the updraft. We are going to present updraft with the letter U, which will now be given by weight in air minus weight in water. We have seen weight in air as 1.0 newtons, then weight in water is 0.85 newtons. When you subtract that, you get 0.15 newtons. Now, the difference in their weight when in air and when immersed in water is 0.15 newtons. This is what we refer to as the updraft force. So how do we define updraft force? We define updraft force as that upward force that acts on objects immersed in a given liquid. And you must be more specific because updraft itself is a force and force is a vector quantity. That means we have to take care of direction. Vector quantities are those given quantities that have both magnitude and direction. So updrastic force acts upward. That's why object mass in a given liquid are going to weigh less, because there is that upward force that is acting on those given objects. And as clearly seen in my demonstration, we have seen that weight of body in water is 0.85, and when you subtract that, you get updrastic force as 0.15 newtons. There is another name that we give to updrastic force. We also refer to it as force of buoyancy. Force of buoyancy. Force of buoyancy. So you can also refer to updraft as force of buoyancy. The other thing that I want us to look now is the Archimedes principle. And for us to be able to understand Archimedes principle, I still have some apparatus with me that I am going to use so that I can verify Archimedes principle. We are going to use this spring balance still. We are also going to use these given masses that I have here. I also have another apparatus here. I want to believe you have ever seen this apparatus. It is called Eureka can, and it has a spout. I also have a thread. This thread is going to tie the masses that I have, and I have other beakers. This beaker is empty. It is also going to help us understand the Archimedes principle. And viewers, I want to end here. In my next clip, we are going to start with the verification of the Archimedes principle with some of the apparatus that I have already shown you. Keep tuned, kindly subscribe, and I believe we are going to learn one or two things we are going to share. And I believe if you are a parent, if you are a learner, if you are a teacher, you have found this clip educative. Thanks and bye for now.